Hey guys, Ms. Miller's making a video from her home, so it's going to be a ton of fun. What this video is going to be about is we're going to learn, right at the top it says the objective of this video lesson. So it says, in this video lesson we will learn to solve a problem where the base is raised to a 0 power. So we're going to learn what are answers when things are raised to the 0 power. So let's take a look. My board looks like your worksheet should. I have 10 to the third. I'm just going to write out what 10 to the third is, and I'm going to put my answer on this side. Well, I know that 10 to the third is 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. So 10 to the third power is equal to 1,000. Go ahead and fill that into your notes. I'll then do 10 squared. I know that 10 squared is the same thing as 10 times 10. 10 times 10 is 100. So I'll put that over there. And 10 to the first power. I know that anything to the first power is just itself once. So this is just 10. So you'll see a pattern. I'm going 3, 2, 1. You can probably guess what would go right here. 10 to the 0 power. We're going to skip this right now and then come back to it. I have 10 to the negative first power. This is what we did yesterday or today, depending on which day you're watching this video. This negative exponent tells me to divide. So I'm going to say that this is 1 over 10. This means to divide once, so I'm going to divide by 10 one time. So 10 to the negative first power is 1 over 10. 1/10. Next one, 10 to the negative second power. The negative exponent tells me to divide. I'm going to divide by 10 two times. So I get 1 over 10 times 1 over 10. Well, 1 times 1 is 1, and 10 times 10 is 100. So 10 to the negative second power is 1 over 100. That was Bruce. You just heard him shaking and wiggling. You'll get to see him. If you keep watching this video, you'll see him at the end. And last, 10 to the negative third power. Again, the negative exponent tells me to divide. So I'm going to divide. This is 1 over 10, and I'm doing that 3 times. 10 times 10 times 10, we knew that up here was 1,000. And my numerator, 1 times 1 times 1, just gives me 1. All right, here's a really interesting thing to look at. You might notice a pattern. We go 1,000, 110. We're not sure what this is yet. Then 1 over 10, 1 over 100, 1 over 1,000. What's happening is every time we're going down an exponent, so we go from 3 to 2, we are dividing by 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. Well, let's do the same thing next. 10 divided by 10. What's 10 divided by 10? 10 divided by 10 is 1. Then if we do this divided by 10, 1 divided by 10. Well, 1 divided by 10, I know I can write like this. 1 divided by 10. I also know that I can show division by making it a fraction. 1 divided by 10. Now we'll divide that again by 10. This is 1/10 divided by 10, which is 100. There's Bruce for you. We keep going down every time it's dividing by 10. So we will see that something to the 0 power gave us a value of 1. Anytime, no matter what the base is, it could be a fraction, it could be a decimal, it could be a negative number, it doesn't matter. Anything raised to the 0 power is always going to give you 1. I'm going to prove it to you in one more way. Take a look at the second example. The second example is 4 to the 5th over 4 to the 5th. Now I want to review some things that we know about fractions before we jump straight into this problem. So I'm going to move down here. I know that 2 over 2, if my numerator and denominator are the same, I know 2 over 2 is a whole or equal to 1. I know that 6 over 6 is a whole because the numerator and denominator are the same, and that is equal to 1. Even if I don't know the number, so if I have x over x, I don't know what x is, but I know that these are both the same value. If the numerator and the denominator are the same value, I know that x over x is equal to 1. So take a look at this. 4 to the 5th over 4 to the 5th. The numerator and the denominator are the same, so this would simplify to 1. Now you might be asking yourself, what does this have to do with raising something to a 0 power? Well, let's think about what we know about dividing exponents. So I'm saying that this is equal to 1 because the numerator and denominator are the same. Let's say we wanted to take a different approach and we said, I know how to simplify a problem like that. I'm thinking back to Tuesday when we did dividing. And I know that if I'm dividing, which is represented by this fraction bar, that I can subtract the exponents. And Zach, you alluded to this the other day. What happens if our exponent is 0? Here's the answer to that question. Well, I know I'm dividing and my bases are the same, so I can subtract my exponent. 5 minus 5 is 0. So this is 4 to the 0 power. And I already know that 4 to the 5th power or 4 to the 5th power is equal to 1. And if this simplifies to 4 to the 0 power by doing 5 minus 5, then this also equals 1. Anything to the 0 power is equal to 1. 12 to the 0 power is equal to 1. 5.6 to the 0 power is equal to 1. And at the bottom, there's examples. 1.3 million to the 0 power is going to be equal to 1. If I have in parentheses negative 2 to the 0 power, that is also going to be equal to, you guessed it, 1. Today we learned that anything raised to the 0 power is just the value 1. Now it's time to say hi to Bruce. Bruce, come here. Bruce. He's really excited to say hi. Bruce, say hi to all my students. Hi! Hi, Bruce. Hi, Bruce. Bye, guys.